Hi guys, how you going? Well, today we're going to be looking at the concept of a definite integral. Now, out of your textbook, I've just cut and pasted this definition out of there. So the integral from a to b of f of x is equal to the answer of what the integral is from b, take the integral of a. Alright, so probably it's easier to see if we do this graphically. So if I've got a function and we are looking at, this has been our f of x on our particular integral. If we're going from a to b, then what we're looking at is we're looking at this area here. So we're actually finding that area bound by the function f of x and the x-axis. Alright, so let's do a couple of simple examples. Now, most of the ones that we'll be looking at in this first section will be bound by the x-axis. Alright, so if we're looking at this first one, the first step is obviously to do the integration, so that's what we do need to do. So because it's a definite integral, we'll start with a square bracket, and it simply is going each term by each term. So x squared becomes x cubed over 3 plus 2x squared over 2, so we can write that as x squared plus x. And then we're going from 1 to 4. Alright, so my thinking, what I've got to do here is simply put into here 4 cubed over 3 plus 4 squared plus 4. And then we're going to take away our other values, so it's going to be 1 cubed over 3, which is a third, plus 1 squared, which is 1 plus 1. Alright, so now it can be a bit tedious doing that sort of calculation on your calculator. Now, if you're not great with fractions, don't worry, don't panic. What I would do with this particular case is I'll come to my calculator. If I come to my graphing, and we'll just put our first function now, I'll just turn this other one off. Right, so if I graph that, that in fact is my function, isn't it? That's the function I just found there in terms of what I'm looking at. Alright, so I'm looking at the integral of that function from 1 to 4. Alright, so if I now in terms of take the integral, so I've now got to go into calc, and I'm now looking at the value of number 7. Alright, so I'm going from 1, that's my lower limit, and then I'm going to 4, and that's my upper limit. It'll actually work that value out for me, so it works out to be 39. Alright, so if I'm now going over here, I can say that actually works out to be 39. Alright, and that would be units squared. Got the idea? So if you want to have a quick check at that, that's going to be obviously 4 cubed. Now 4 squared is 16, 64. 64 divided by 3 is roughly about 21, plus 16. So 21, 36, plus another thing is about 40 odd. And this thing over here is going to be fairly minimal. Okay, so that sounds about the right answer. My calculator does it for me, takes out the guesswork, saves me a lot of time. I think that's the way to have a go at these sort of questions. The really important part of that is I've showed that I can actually do the integral. I've shown the substitution. Apart from that, I just want to get my answer. Alright, now there is another way of doing this, of course. And if I go to my calculator, go to my math, pick on maths again. If you scroll down to my fint, okay, so I'm going from 1 to 4. Hang on, let's go to, what have I done? Alright, so if I go from 1, I'll just clear that and do that again. Quit out of there, done something strange. Just quit. So number 1. I'm having a mental break, so clear that and let's try this again. So if we go to math, coming down, scrolling down to my fint, so I'm going from 1, using an up arrow, going to 4, going cross arrow, I'm going to put in my function, which is in fact x squared plus 2x plus 1, and then I'm going to my doing that with respect to x. It gives me my answer. So that's another way of doing it, so you don't even have to graph it. Right? As long as you know that it doesn't have a turning point that goes below the x-axis, then that process will work quite well. All right, so that's my first example. Scrolling down here, we'll have another go at another example over here. All right, so if I've got this particular function, again, I could just put that straight into my calculator and work that out. I think it's probably going to be easier and not really part of the process to show that you can do the integration. So let's do that first of all. Now I'm thinking of this function over here. I'm thinking of e to the ax plus b. That's going to give me 1 over a e to the ax plus b. Right, so that's what I need to think about when I'm doing this particular function. In this case, my a value is in fact -2. All right, so when I go and write this, that's going to be 1 over -2 e to the 1 take 2x plus 3x. All right, and that's going from 0 to 3. So when I do my function now, if I ask you for an exact value in the question, then I'm asking you really to do it algebraically, all right, not using your calculator. So the exact answer there is going to be equal to -1/2 e to the 1 take 2 times by 3 plus 3 times by 3, take away -1/2 e to the 1 take 2 times by 0 plus 3 times by 0. Now obviously that goes out, then I can write this as simply equal to -1/2 e to the, now that's going to be 1 take 6, that's going to be -5, and then that's going to be plus 9. Then I'm going to be taking away, that's going to be a -1/2, now that's going to be e to the 1, and that's going to be 0. Alright, so I probably really didn't need to use a bracket, but the idea of not losing the negative there, so that's going to give me, you can rewrite this if you want to as -1 over 2 e to the 5 plus 1 over 2e, sorry, no, I've done that wrong. The e's got to be on the top line. So we can write that as net plus e on 2, and then we're going to go plus 9. All right, so that's in terms of an exact answer. It doesn't have decimal places. Now, if we want to check what that particular function is, we go to our calculator. We'll just clear what we did last time. Go to my y equals. I'll turn that graph off because, and then this is the function that we're doing. So if we go enter that, we'll turn that function on, and then we can graph that. That's what it looks like. Now we're interested in, I think when you're doing this, it's just as quick to do it this way using your G-calc. Go to number 7, go to 0, enter, go to 3, enter, that's my upper limit, and that gives me a value of 10.35, say 6. Now if I was going to 3 sig figures, I think you could go and say 10.4. It would be quite close enough for what I'm looking at. Remembering, unless we tell you otherwise, 3 sig figures is perfectly fine. So that's 10.4 units squared. Here's my answer there. Now, obviously the other way of doing it on your calculator is in fact going to your math button. So if I quit out of there and I go to my math button, coming down. Now, if you remember what the number is, you can go straight to it. So you can type in math 9 and that will bring this thing up. So int. So remember going from 0, using up arrow going to 3. Now, if your calculator doesn't have this operating system on it, the same thing, you're just using commas instead of doing this thing. So my function was e to the power of 1 take 2x. And then that was plus 3 and then it's a function of x. Alright, so when I do that, I get 10.34, which is exactly what we get. So you've got to work out for yourself which one's the easiest way to check your answer. Keeping in mind that if it asks you to find the exact answer, then this is the one that I'm looking for here. I'm looking for you to keep the E in there, otherwise it will be the wrong answer. Let's do one more for just for the hell of it. So let's go for the integral of, say, -1 to 1 of x cubed dx. Alright, so let's do that. So obviously when we're doing our integral, we're looking at the definite integral, so it's going to be x to the 4 on 4. Alright, so it's going to be 1 and minus 1. Go into here, so that's going to be simply 1 to the power of 4, 4. And then I'm going to take away from that, I'm going to take away -1 to the power of 4 on 4. Now that will give me an answer of 0. Okay, let's look at why that's the case. In terms of, let's go up here and we'll just clear these things here and clear this graph here. Let's put in x cubed, x to the power of 3. Right. And we just set our window from -5 to 5, and let's go from -5 to 5 and graph that. Right, you can see it sort of does that inflection point. So if I'm looking at my integral from that, let's go back to what we were talking about. If we're going from -1 to 1, then what you will see when we're doing our graph over here, it's number 7. Right? So if we're going from -1 and then going to 1, I've stuffed it up, sorry. Let's graph it again. We'll do the doing number 7. We're going -1 and then we're going to 1. Right, so they're below the axis and then we've got above the axis here. So those two areas are exactly the same, so therefore we're looking at getting an answer of 0. If I wanted to work out the total area, like had to paint that, then I'd have to work out the area from, say, -1 to 0 and times it by 2, because they're going to be exactly the same. All right, we'll be looking at some more function stuff anyway later on, but I think it gives you a bit of a good idea in terms of what you've got to do. So good luck with those questions. Make sure you catch me in class if you need some help. Bye for now.